you. Thank you. Thank you, organizers, for giving me the opportunity to come today here in Washington for this, I think, very interesting conference. It's the first time that I'm participating to a conference on of this topic. Yes, my specialty is in economics, but I started working a few years ago on issues related with surveys with Bank of Canada. And this is a paper that I'm working with Kim Huynh, who is present here, is from Bank of Canada, and Anna Chernesky. The title, I am so tired, I don't know what to do, Fatigue and Financial Literacy, Results from a Randomized Experiment. This experiment is not coming from a probability sampling. But we are actually benchmarking our results to see if the results are influenced by a probability sampling that is, let's say, run by Statistics Canada. Then I should make a disclaimer here because these views are expressed by those by the authors and are not the responsibility attributed to the Bank of Canada. And they are also preliminary, then we are continuing to work on it. I mean, we find some interesting results that I think will be worth it to look at it. And what we are doing on this paper, as I said, we are going to use a non-probability sample run by Bank of Canada. And I think in this room, 3 of the people that were at the original of this sampling that was done in 2020 is Kim, is Hank, and is Graydon. They were the original people that were working on that sampling, but the sampling was looking at, it's a cash alternative survey, and was looking at questions about cash, or how cash was affected by COVID. It was a survey that was run in November 2020 after the first wave of COVID. Now, in that survey, besides, let's say, the questions that were related to cash and COVID, there were also some financial literacy questions, and they were designing AB type randomized experiment where financial questions, which are viewed as more difficult questions, were placed either at the beginning of the survey or towards the end of the survey. And looking at trying to see if there is an effect of displacement on the answers and who are the origins of these, let's say, misuse or of, let's say, saying incorrect answers versus correct answers. Then the question that we are asking is, does the placement of financial literacy question affect the responses to these questions? And we are evaluating the impact of these financial literacy responses. And practically, we do this in 3 stages. First, we are looking at, by this design of the questionnaire, we are testing to see if there are differences across the correct, incorrect, and no answers in these 3 financial literacy questions, big 3 by Lusardi and Mitchell. And here I should discuss the big 3 questions. They are not that difficult for us, but maybe difficult for other people from the survey. First question relates to, let's say, to the interest compounding. If you receive, for example, $100 today, and you have a 2% interest rate in 5 years, do you have more, less, equal, or you don't know? A question about inflation, the same if you have an interest of 1% for $100 and inflation is 2%, then in 1 year you have more, less, equal, or don't know. And a question that relates to risk and risk diversification. If an asset that you receive a return on an asset is higher or lower, or you don't know, relative to, let's say, a mutual fund of different assets. And based on these three questions, we see that practically we investigated if displacement affects the answers, especially the correct, we are looking correct, incorrect, and don't know answers. Now, besides the fact that we see differences, we want to understand what drives those differences. And to understand that, we look at some Osaka-Blinder decomposition, we look at the contribution of the observables and unobservables, and we wanted to see if the difference is driven by what we observe, by the characteristics of the individuals, or if differences are driven by the unobservables, and if is the case for being driven by unobservables, what's actually behind these unobservables. And if we also probably think that as we found that 80% of the responses are driven by unobservables, we were using some propensity score matching to address the selection that may impact that impacts due to unobservables. And we see that this selection effect reduces the total effect by 20–30%. But what I wanted to say is that, as I said, the survey is quota-based, and the quota is based on age, gender, and province, while, let's say, the randomization is also done on age, gender, and education. Then there may be some selection that comes from the differences of the quota versus the randomization, or maybe a difference that might come from the, let's say, the fact that there may be differences relative to the population surveys, the one that are, okay. Yes, and or maybe differences that are due to the fact that people may not answer everything in the same time. But I want to show you the frame of our survey. Then we have financial literacy at the beginning, group A, payment usage, main credit card, cash holdings, perception about cash or credit card usage, identity theft, and information about questions about COVID and Bitcoin question. And the group B, we have the financial literacy after the credit, cash holdings, payment usage, but before the ones that talk about COVID and Bitcoin questions. Now, if we are looking at the differences between group A and group B, what we see that, for example, the first question is on savings. We see that people are more correct on savings in group, and the risk question is the one that probably is the most difficult perceived, because we see the number of don't know are the highest there, while the correct answers are very similar with the one on inflation. But when we move to group B, we see that there are differences. These differences, let's say the correct answers are dropping across all the three questions, and the don't know answers are increasing along all the three questions. The ones that are stable are the incorrect answers, yes? Now, when we do these decompositions by Osaka-Blinder decomposition, we see that in general, what drives these differences across the three questions, we see that the question 3 about risk has the highest difference, but what drives this difference is are the unobservables, the coefficients in our table. And we see that that's true for correct and don't know. For the incorrect, we see that only one question, there is some difference. And if we are looking at the matching, the PSM, we see that there is a reduction across all, but we don't see differences on incorrect answers. Then the PSM answers, PSM practically for incorrect is the same as the one with Oaxaca blinder decomposition. That provides information to us because it's practically tells us something about, let's say, how we probably should benchmark these surveys. Because we see if we benchmark on correct answers, that will be probably incorrect, given that we have probably more unobservables that explains the answers, the correct answers. While if we place on the incorrect benchmark, there is less variation due to observables or unobservables, and we should probably benchmark our results on incorrect answers when we do classification of, let's say, indices of literacy, for example. But we zoom in also on these unobservables, and what we found that there is a gender gap. This gender gap, we found it in other surveys, and other found this gender gap. And we wanted to see if it's exacerbated. And indeed, what we found that there is this gender gap is exacerbated by the fact that, for example, females that are working or higher income and they have kids, the difference is increasing on the don't know answers relative. And yes, yes, I think that I'm done. Yes.